Guys, welcome back to another tutorial on getting started with Sparks. So you are supposed to go to this file. It's created in the source main Scala and then chapter 2. So chapter 1 was all about installation. I hope it was very comprehensive document, nothing much, just the details of how step-by-step procedure. I hope you are clear with this. Now in this one we will just see how we can get started. So you need to open this file. Okay, so let's go there. All right, so first thing is we'll learn about RDD and data frames in Spark, like what is a RDD and what is a data frame. Okay, and then we will go through other questions. So just to know, we'll also try to cover the theoretical concepts because they are very important as we go, and then we will see their practical implementations and all. Okay, so RDD and data frames are two different abstractions. Okay, they are like not very different because data frames are written on top of RDDs only. But yeah, RDD lets you give more flexibility to control over the text and everything. So it's a low level immutable distribution collection of objects. It offers more control, meaning that you can do more data manipulation the way you want to control the, each bytes of the data, whether it be text file or any unstructured data, it could handle it well. And it doesn't have optimizations, of course, because it's very raw format. Catalyst optimizer is one of the coolest feature of Spark data frames that we will be looking into the upcoming videos, and then the execution engine as well. Data frames are like high level APIs built on top of RDDs that offer optimizations, SQL-like interface, support structured data, and they are easier to use and more performant due to all the optimizations that Spark does over it, like Catalyst optimizer and Tungsten execution engine. Okay. And now when to use RDD and when to use data frames. Okay, so this could be one of the questions that you might get in maybe in an exam or in an interview. So RDD is basically, as you got the intuition right, so RDD gives you the flexibility to control data the way you want to. If the data is very unstructured, very unformatted, and you have a specific way of processing it, that's when you want to go for RDDs. Okay, so RDDs are useful when you need fine-grained control over low-level transformations, like every single thing. Okay, you're working with unstructured or semi-structured data. That is the very important key. So when the data is unstructured, like let's say an IoT sensor is sending some data to your server, continuously, and there are some junk bytes in between, and you have some pattern to identify that and then remove it out. So that data is very unstructured. It's just pumping in data in a real-time streaming fashion or anything. So that is when you want to use RDDs, and you prefer strong type safety and are more comfortable with Scala's programming construct, because RDDs are more built on top of Scala programming, functional programming constructs. Okay, now coming back to the data frames. So data frames, when you're working with structured data like rows and columns, and you want to use SQL queries. So again, these are supported out of the box for data frames, and you have performance things. So Catalyst optimization is something that will help you increase the performance for read, writes, and all those things. And you want to use built-in Spark functions. So there are a lot of Spark functions that we are going to explore now after in some time, in upcoming lectures. But yeah, and how to read a text file. This is again, now this is the next part of things. So how to read a text file in Spark, how to convert RDD to a data frame, and vice versa. When you convert RDD to a data frame, it's not like magically it will just try to figure out all the rows and columns. It will be very naive conversion. But again, because we want to know how we can transfer these two, just for that purpose we will be exploring that. Then we will see line count of a given text file. Okay, so given a text file, we will try to read it, and then we will see how we can count the lines and all those things, and the word count of given text file as well. And then we will understand the SparkSession. We will see how this works and all when we start to code. Okay, so let's get started and write some code. So first thing will be to create a SparkSession. So if I go to chapter 2, you make sure that this import org Apache Spark equals SparkSession is there, and make sure that in the build.sbt you have all these files. So in this one, Spark core and Spark SQL. For the command, you can just run this thing sbt, and then you will see the sbt shell, and then when you want you can run it, etc. Okay, anyways, so for compiling you can always run compile. You can clean compile also. So first run clean and then compile in order to compile it after any dependency refresh or anything. Okay, now you have this thing. Let's start with a private val, let's say spark equal to SparkSession. So in Spark 2, we have all the sessions managed in under the SparkSession. So all the unified APIs and as you can see, it's saying entry point with dataset, DataFrame environment, and then like lots of everything that we used to have in distributed way. Now everything is in this, and then we will do dot builder to build up a particular session, and basically this is a configurator. Now you can configure on top of this a lot of things. One of those configurations is app name. So for this case, we will just say it's chapter 2. And once we configure the app name, then we can just specify the master. So master tells about the cluster details, like which cluster to run on. Generally, it's known as master URL. So in our case, it would be local. And then we can specify how many cores, like 2, 3, 23, 24, depending upon the core size of your CPU. And if you do star, it means all the cores, you utilize all the cores. And then masters, then you can do just get or create. So what does this do? As the name specifies, if the instance already exists, it's like that singleton property that you may want to have. So if the instance already exists, then it will just get that instance. However, if not, then it will create a new instance and then it will return that instance. Okay, so I hope this first part is clear to you. This will be like the base part. And every time you complete the program, you also need to do spark.stop, which will free all the resources that was being used by this. Okay, even in case of unexpected shutdowns. So this is a very very basic boilerplate setup. Now we can go around and play with the next steps. Okay, so let me save this. Let me go here and understanding the SparkSession. So as you can see, we have it here, and this is the main entry point created. Since Spark, as we discussed, it's a unified API for working with Spark functionalities like RDDs, resilient data, data frames, data sets, encapsulates both SQL context and Hive context APIs. And I hope you, mostly you won't be aware of these like basic context. So we will discuss this once we go along. And then builder initializes the configurator that we need for the use case, app name, useful for logging, tracking, and all those things. And yeah, this basically, when you put this, whenever you get any logs, you will get context in app name as this one. And then the master set the cluster manager, master URL of the cluster manager, and this supports several cluster managers, and the master URL determines whether the Spark how to run the job. Okay, and this is again the URL on which it is supposed to run. Star specifies all the CPUs that can be used, and 4 cores. Yeah, this is already we discussed. And Yarn is yet another resource manager. So it is one of the very popular resource managers in the Hadoop ecosystem mainly. And we will see what is the differences and how things we can configure as we go along. But let's first see the other functionalities of the Spark. So in this one, we needed to cover, we already had this thing. Yeah, how to read a text file in Spark. Okay, so let's go with these ones. So let me just copy this and go back to the chapter, and let me put a multi-line comment here. Okay, sorry. Okay, let me just quickly maybe indent these. Yeah, and then let me, oops. Yeah, okay, how to read a text file in Spark. So there are 2 ways. One is through your RDDs, and the second one is through DataFrames. Okay, so let's see the example one by one. So private val. Okay, so, and even before that, let's specify the path. So private val path to text file equals to, and let's see. So here we, in the assets, we have this example.txt file. Okay, and we can see how to get access to that. So we can just do from the root, we will have src. Inside src we will have assets, and assets we have sample.txt. Okay, So now since we have initialized the path, we can do private val RDD text equals to spark dot spark context dot text file maybe, yeah, and then path to text file. Okay, and then this basically will give me RDD text, which is of the type RDD string. Okay, and for now we can do RDD text dot collect, which will basically collect all the strings, and then for each println. Okay, I hope the syntax is familiar too, other than this part, for each println, which is standard Scala syntax. This basically helps me to collect all the RDD text in multi-line and then println. Okay, so let's run and see what this does. I'll just go to my SBT shell. Okay, so this is my SBT shell. I opened it using SBT command. You can also do the same thing. Okay, and now since I have only one run class, so I'll just run this one, and it's compiling. Okay, so we got an error saying inputs file. Okay, I guess there is an extra space here. Let me run it again. Okay, so it completed finally, and start from here. So if we go and open the wait, I think I need to get rid of this sample.txt. so you can see start from here, and this is a readme file containing and all this, and then this. Okay, so this is how your RDD looks like. Okay, it read it line by line, so by default it reads by line, and then it is giving you all the details. Okay, so let me again open chapter 2. So the first time through RDDs and DataFrames, so through RDDs. Okay, so this is how you will read a text file. You could also perform operations on RDDs, like let's say word count. We will see the word count at the end of this part. Line count also we will see. A line count is anyway straightforward, but let me do it. RDD text dot collect dot length. So this will give me the line count of the given file. And then I hope you are aware of syntax formatting, and not syntax, string formatting. So this is what I'm doing. I'm just adding this line, and I guess it will again take long. So maybe let's, from next tutorial we'll switch to IntelliJ. I don't know why it's taking this long, and even after subsequent runs. So we will switch to IntelliJ for better speed and all. And meanwhile I'll just, so word count we will see at the end. We'll also see how to read through df. So through df we have simple private val actually df text equals to spark dot file. What is spark dot file? I think spark dot read. Yeah, spark dot read dot text. Again the path to text file, and println, not println actually, df text dot show. So as simple as that. What is it complaining about? Oh, I have one caps. Okay, yeah, so you can see count line is 3, and if we open the sample text, it's 3-line file. Okay, and similarly here also, if I close this and run it again, so this time it will give me in a df format. So we can see what is how it's different from df format. Okay, and let me put some. And then next thing is word count, but before word count,
it's 14:30.
we will see conversions. Okay, convert to data frame from RDD. Okay, so for this we need to import spark.implicits. Okay, and then we need to do private df from RDD equal to RDD text dot to df, and then we can specify how we want to distribute the columns in even the data frame. In this case it's line wise, so we will just get the df from RDD, and then now this is a df, so I can just do df from RDD dot show. Okay, so you can see that this is line wise how this data frame is showing up. It's now a table, right? So that is what we had discussed in this. When you have a structured data like rows and columns, df is better because now you can access the value that is the top column. I mean, again, it's without header, so it's starting from here, and then you can do value dot contain, something like that. You can make the SQL queries also out of this. So that is what when you use data frames. Okay, now let me clear this and run it out. Meanwhile, let this run. We can go ahead and look for convert convert to RDD from data frame. Okay, this is much straightforward. We don't need to do anything. We just need to do private val RDD from df equal to df text dot RDD. That's all. Okay, and then we can just do RDD dot sorry, to print no RDD dot collect dot for each println. Okay, so yeah, you can see that the above two. So we have it like this when we try to convert actually RDD from df, and let's have a print line statement so that we are clear. Convert to df from RDD, convert to RDD from df. Okay, line and all. So this is basics. I hope you got the idea. Now we can see yeah, now it will be better if we run it now. Yeah, so we have convert to df from RDD, which is like this. This was the initial one, and line start from here because line is because we specified you know, the this particular thing to df. So if we see the method collection names string start, so basically you can, it maps all those to this names. Okay, so if you have like multiple splits, you can specify. So let's say if I do it instead of line, I do it maybe something else, and then if I run it again, okay, now it's running pretty fast. Okay, anyways, so here you can see something else is coming, right? So that is the role, basically providing a header and all. Now convert to RDD from df, RDD from df. So you can see that it's coming with these square brackets, and this is tutorial. Okay, so this is about the first part. Now let's go to the word count program. Okay, so word count, I mean, this is specific operation for RDD file. Okay, so I mean, you can do the same thing in the this thing also, data frame, but just to show how flexible RDDs are, we will see this example. Okay, so let's do that. Okay, but I guess first we need to, okay, so if you see RDD, it's basically line split values, right? So what we will do is, for that, like let's say line, we will map that line to line dot split, and then split based on spaces. Okay, now this map will basically for each line, because we have each line, so it would be something like that. Let me help you visualize this. So currently it's something like this. Oops, what just happened? Okay, my copilot is going crazy. Yeah, so if I go to this one, no, so its first line is this. Okay, and then comma, the next line is, let's not go all the way, let's just take this for understanding this. Okay, Okay, so this is the line. So when we do a map, it will basically return me another array, and this array would be first would be having something like yeah, so start, and because we are separating from spaces, from comma here, and then it will go to the next array, and then it will be something like this. Okay, now we don't want this array, right? We want these words to be coming like this, so that we can perform our operations on this to count them. Okay, so for that, instead of map, let's use flat map, which basically flattens the entire sub arrays. Okay, now line with dot split, flat map, dot map. Now this time for each word we want to map this to, like we want to create something like this, start comma 1, and since we want to take care of the cases, so we can actually make it lowercase also. Then the next word would be from comma 1, and similarly here comma 1, and so on. We will map all of these. The last would be containing comma 1. Okay, so the map we will say word, and then word we will do it like this, word dot to local lowercase comma 1. Okay, so let me put it in the next line, and now so this will give me the result. Now I need to merge all these, so I will just use simple method reduce by keys, and this will give me all the keys a comma b, so key 1 comma key 2 in basic terms, key 1 comma key 2. And what I'll do is I will just not key 1 comma key 2, because we are already doing reduce by keys, so value 1 comma value 2. So this I will reduce it to value 1 plus value 2. Okay, so this is wait, what is it complaining about? Reduce by keys. No, it should be no by keys. Oh, sorry, it's reduce by key, not keys. Okay, I hope this time yeah. So this will give me so for each key, like start, so basically this will now go like this. This will give me start comma 1, then we have what, from comma 1, and so on until, let's say, start repeat, so this will become 2, and like that. Okay, so this is our number of words. Again, this is also I hope you got what all this is, and this will return me RDD of string comma int, where string is the word and int is the count of it. Okay, so we'll do number of words actually dot collect for each println. Okay, so let's see how does this go, and let's remove other println. I think we already have a lot of these, so not to confuse you. Or maybe instead of removing it, we'll just comment these out. Okay. Thing that I wanted to add is that it's better if you turn Java 8 on. I mean, there's ways to set the environment variable Java home and then turn it on, because there are some things about Scala specifically, not Scala, sorry, Spark specifically. You will get some illegal reflective access warnings if you don't. I mean, you don't need to worry about it, but generally you get that. So I've just turned Java 8, and now since we are here, so let me just run this file. So I'll just go and run. So you can see that this is the output of the entire word count file that we had. Okay, so this is one of the ways to count the words. I hope you got it. This is a very basic operation, but you should be clear what each line is doing. As we discussed, flat map will make sure that all the arrays, sub arrays, are again transformed back and flattened into a normal array, and then the map would basically convert it into a string and a number, and then reduce by key will basically take all the numbers and finally give us the result as the sum of those numbers each time that key occurs. So, and then we are printing it. Okay, So this whole example, I hope you are clear. Now let's do this with data frame. Okay, so here we had data frame df text spark.read.text file, so we'll do it from here. Okay, so in order to first see, let's first actually see the df, because that is important. We need to know the headers, because that is what we will be using for the count operation. So yeah, so what will happen is we'll have the column, and then we'll use that column to perform some df based operations. Okay, so you can see that it's starting from value, meaning that that's a default header. Okay, so now what we can do is private val df word counts equal to not RDD actually, df text dot we need to do SQL dialect. Okay, so select, let me put it a little bit here, and then what we need to do is explode. We will do split column of value, and we want to split it by spaces. Okay, so that would be one thing, and then as word. Okay, so let's first see what is it complaining about. Value not found, explode. I guess we need to import these. So let's import these org dot wait, let's see if it gives us the suggestion here itself. Quick fix. Okay, it's not org dot. I mean, these things would be better if you will be doing in IntelliJ. So maybe in some of the tutorials after this we'll switch to IntelliJ only. SQL dot functions dot call comma explode comma what else do they need, split. Okay, so select explode split call as word. Okay, let's see one by one. Okay, what this is doing. So what I'll do is df word counts dot show. Okay, we could actually have done the same thing for this one also, RDD text, but because it was more simplified way, so that's why I'm doing it here. So let this run. I think it's taking. So basically we are exploding based on the call value, which is default column and spaces, and then casting it as word. And yeah, it's taking pretty longer. I think maybe the operation is happening for the first time. Maybe that's why. Let's see. And once we are getting this, after that we will just do this thing. So we got it, then we'll group it by and then use the count function. So word count of the given file, I think we can comment this one out. We don't need this, and let's have println. So this will help us give a more context. Okay, I mean more clarity, not context. We'll be seeing clearer logs. So I hope this time it doesn't take that long. By the way, feel free to skip this part. I'll tell you an interesting insight why this happened. So if I keep on compiling it again and again, okay, it came. So there is a JVM heap which basically sees which code is executed again and again, and based on that it will cache that code, and you can actually specify those caching size in the JVM, and then the more you execute it, the smartly it will decide and cache that code execution, and it is pretty fast. Anyways, so you can see that this is how it's showing up. Word count with data frame, start from here, this is, and so on. Okay, so that's one thing. And now what we will do is, so we have all these things running around, and then okay, so that's yeah, So one thing that I see is that we could actually, it's showing only top 20 rows. Yeah, that's what I was confused about, like, because we have more than this. Anyways, so now what we can do is we can just let's df word counts, df word count actually. Okay, fine, let it be anything, whatever it is. Now we can do the next operation. We can do it right away here also, but let's distribute it. Private val df aggregation. So df word counts dot group by, and the column name would be word, and we want to perform the count operation. That's all. So if I do it like this and then run it up. So yeah, that interesting thing that I was talking about is, when the JVM actually, I'm forgetting the term, but yeah, there are two types of cache in the JVM. One, you can specify which particular, you can specify that cache size, and if you, put it, JVM executes it, and the compiler intelligently identifies which particular part of code to run again and again. And once the part which is being again and again run, it comes into the cache, the execution becomes pretty fast. Like, this is one of the optimization techniques of JVM being used to run your code fast. Okay. Yeah, so finally we are here, version, comma, if, and all these things. Yeah, again, only the top 20 rows it's showing, but this is, and there we can see that there are different types of point and all, and also we could have turned the lowercase. So split column as word. The easy way would be, we can actually lower, and I guess if we directly apply it here, should be working fine. Let's give it a try. Okay, so yeah, regarding that JVM thing, we will see, like you can see now it's taking a lot of time. Oops, I got some errors. I think not at on top of split actually. Let me think. So we have explode, no? I guess even before explode we need to put explode is actually creating, no, I think here, my bad. We could just put it here now because we are accepting the column values. Okay, let's run it again. Yep, so it's lowercase, as you can see, all of these, and that's how it will be optimized. Okay, so that is one thing. We can do this df aggregation dot count dot toInt and truncate equal to false, so that it won't truncate any, like if our horizontal line goes ahead, it won't truncate, it will be horizontally scrollable, or it will basically split into the next line so that it shows the entire content. So let me run it again. Yeah, and by the way, this caching thing was introduced after JVM 1.4 or something, I guess. So yeah, you can see that it's now showing all the rows, start and all, everything, and we can do pretty much a lot of things from here on. You can see that earlier it was showing only 20 rows, so you can say in a lot of ways the data frame part is quite optimized. In RDD there is no such scope because it can overflow your terminal, and it can cause issues like if your terminal is having a lot of buffer memory, it may make your entire terminal unresponsive and all. So those things are taken care of. So generally you shouldn't do this unless you really want to, and this should be the ideal way. So yeah, I hope this tutorial was clear. You got to learn about RDDs, resilient distributed datasets, and data frames, and when to use one and what are the differences. I hope this was very helpful. In next couple of tutorials we will further move into some more advanced functions and see how those works. So I hope you like this content. If you have any questions, feel free to drop in the comments, and anything, if you have any suggestions about my video, like if you are not able to hear me properly, or if you want some more elaboration and all, please feel free to drop in the comments. That helps me improve and deliver the best content I can. I'm trying my best to cover these topics, so if these topics interest you, you can consider subscribing. I will be looking into big data and AI ML. I have been making content on full stack development, automation and all that stuff. But yeah, there's a lot of things that we will explore throughout the journey, and let me know if you have any questions, anything that you think could be improved or anything. Feel free to drop in the comments. Until then, I hope you will be doing well, and see you. Okay, bye.